Hello and welcome to the channel. So we're back with this Bell 3710A, and if you remember, we needs a full recap, and we're also going to mod it to a 5C3. And if you remember, we powered it up both times. The first time we powered it up, the output transformer was blown, so we changed that, and then we powered it up and we found that we'd got very low plate volts. Now I've got to the bottom of what that is, and I'll explain that in a few minutes. But the first thing we're going to do is we're going to change this capacitor, the can cap, which we took off in the last part. So this is what I've come up with. Because this is only a 25mm hole, then obviously a 35mm cap is not going to be safe in there, because terminals will be too close to the edge of the chassis. So I've come up with this. So this is an F&T 33 plus 33 at 450 working volts, which is plenty, and this bracket here. So what we're going to do is that goes in the bracket, and we'll tighten that up. This is the ground. We'll fold it down. We might have to just J-hook a piece on. We'll fold it down, and then we'll ground it onto the bolt. We'll put a tag on there and ground it there, and that'll be fine because it's only ground. So we can leave that exposed above the top. These two prongs here, one will be for the plate, one will be for the screen. We'll insulate these so they're just like wires, and then we can just connect onto those, and that's the best way of doing that, I think. And if we turn this over like so, and we're on a different camera at the minute, so that bracket fits perfectly over those holes. He slots in there, and job's a squirrel. Right, so I'm holding the camera, and we're looking at this transformer now, and someone said in the comments, why don't you look on the label? Well, I had looked on the label before and you couldn't read it, so I decided to try and clean this label, and took some alcohol to it, and I thought, well, it's either going to dissolve it or it's going to clean it, and it has cleaned it, and it is now readable, which it wasn't before. So if we go in and look, and I get something to point with, you can see that I uncovered red 300, so that's what you couldn't see before, and you also couldn't see any of this. 70 milliamps, you can just about make that out there. 70 milliamps, that was covered over. And then we've got red there. Sorry, I'm dropping that. Just going a bit, see if we can go in closer. So yeah, you can see it now. 300, 70 milliamps, and 2 red, so that means red. So that's not powerful enough, so we need a new transformer for this amp. So, and I've got Michael at Modulus Amplification on it at the moment. I've sent him some photos and measurements, and we're going to have to replace that, I'm afraid. Right, working outside again as well, lapping up the sunshine. So I've removed the transformer, and here's the offending item, and you can see that yes, we're well rid of that. So cleaned out everything. Now we're going to have some new grommets in here, get some grommets in here because they're a bit sharp. Get rid of that, that's where the ground was. Get rid of that. We're putting a switch on the back here, so sorry, not here, putting a switch on. So we've got all the power supplies been wiped off now completely. So yeah, and we can see inside, you can see Billy Bodger's hole there for the power switch, power cable. So we can clean that up. We can get in now, everything's out, so I'm going to clean that up properly. Made a right mess of that. somehow managed to dint the chassis on one hole while I was drilling it. I don't quite know. This hole here, if we look, you can see the chassis is dinted there. I don't know how they've managed that, so we'll clean that up as well. That's where one of our input sockets is going, in there. Oh, you can see the whole chassis is dinted. So don't know what they used to hack that hole with, but we'll try and clean that up. I think I'll solder the chassis, the chassis ground, the earth ground on here, I think. So we'll get rid of this. Yes, that drill bit has had quite a bit of use. There we go, that's got rid of that. Right, we've got this capacitor fitted now with our new bracket, and that is all nice and solid. We've got Pink there, who's after food, and I think we're going to have to shut down soon and administer the food, because she's going to keep harassing me. This is the transformer that's come from Modulus Amplifications, and we're going to fit this transformer on this amp. So we sent all the measurements to Michael, and yeah, that fits perfectly. So we've just got to, obviously it was self-tapered on there, so we just need to drill the holes out, get some bolts in there for that. Got all the cables here, but we've got a nice big hole with the grommet there for the wires to go through. So if you're looking for a power transformer or an output transformer for an amplifier, give Modulus Amplification a call. Michael makes excellent transformers, and all these are hand wound and they're absolutely spot on. So that's being fitted on there. If you remember in the last episode, we blanked these off and we're going to drill those out for the jack sockets. We'll now have a 240 volt cable on it instead of 110, because if you remember this, the last transformer that came off was at 110 volts. Right, we'll sort Pink out a bit of grab, and then we'll get the drill out. Right, we're going to start to fit this transformer, and you can see I've already got the filaments in there for the 5 volt feed for the 5Y3 rectifier tube. And if you look closely on here, I've got some tie wraps on there, which I'm going to snip off that one. So what I do is I put tie wraps just where the wires come through the grommet there, so I can twist the wires, and what that does is takes the strain off in the transformer where the wires go into the transformer, so we're not twisting them all the way in there and putting pressure on them by using that tie wrap there. That just, they twist against the tie wrap. It's just something I do when I'm fitting these things, or started doing, should I say. Sorry about that. I caught the camera with my wrist, it's right in front of me. So then you just go in and snip that off there, and that's absolutely fine. So we've got, and these most of these colours on these transformers are usually the same colour as they are in some of the Fenders. In fact, most of the Fenders, because this really is a standard Fender transformer replacement for such amps, you know, like Princeton's and so on. Those type 6v6 amps. Michael does tend to make these transformers pretty much to spec on the Fenders, and it'll be ideal for this amp because it's, you know, we're converting this into a 5C3 anyway. So the red is the AC secondary for the HT voltage B+, and then these brown and blue are the primary, which is this our primary wall colours are brown and blue. The green, that's 6.3, so that'll go to the 6v6s and the preamp tubes. We've got a black wire which is centre tap, and then this ground which goes down there which is centre tap, this, well, ground coloured wire, but as well there. So, and that's probably the ground for these filaments, for the centre tap, sorry, it's probably, that'll be the centre tap for these filaments. I'll just double check that, but it should be. So or we always check. So I think I'll solder these to ground with the big iron. So we're just looking at the schematic, and we've got 0.05 microfarad there. Well, obviously these are 0.047, which is close enough, so I found two of those, and we've got a 0.1 there, and I have got those in the mustard caps as well. So we've got a couple of 0.1s going in there. We may change this slightly, this input arrangement. And then we've already fitted those two there. That's looking good, so we'll use those and remove those Sangamos. So there you go. I've treated you there, Kieran. If you're watching, well, you will be watching because it's your amp. And they will give this amp the extra gumption that it needs.
Gumption, 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 gumption.
Right, we're back outside doing a Shango, and done quite a bit to this amp now. So we've got the power cord in, got the fuse connected up, got the power switch connected up, got the ground soldered here, soldered the grounds, the centre taps for the transformer, for the secondaries, for the filaments and the HT, wired up the speaker sockets, and we've added this tag strip in here because we're going to use that for mounting the third node capacitor and wiring up the centre tap and everything else. Nodes 1, nodes 2, we've got those capacitors here. And the other thing we're going to do is on here we're going to drill a hole for a fuse, HT fuse, and that will be the last hardware I think that we need on this amp, because what have we added on here? So we added the tag strip, the switch, power cable with the cable gland, we've got this plate on, we've added the jack sockets, 2 input sockets, so there's quite a bit of stuff going in this amp. And the capacitor, if we look again, if we just remind ourselves, so if we look, we've got the ground still to do something with here, so we've got to bring that through. There's actually plenty of room to get that through there, so we're going to bring that ground through and then we're going to sort that out. Right, we're moving on a little, so we'll just have a look at what we have done so far. So you can see we've started to wire up this power supply section now, and so let's just look through. So we're starting from here, which is pin 8, and this is the feed from the rectifier tube, the 5Y3 that we're going to be using in this amp. And that wire comes along the back of here, and you can see I've got those wires just about. See, can you just lift that up? It's not very heavy. There we go. We'll go on to manual focus as well, otherwise every time I go near it, the amp will go out of focus. So that wire from here, from the from here, from the rectifier tube, goes along here and goes to the tip of this HT fuse, which we've added there. You can see comes out the fuse, goes to here, a very short journey for it, and that is the first node. This is center tap here, so that's wired up to that same point. This is the drop-in resistor for the screens, the 10k, and then we've got another wire coming from here, going along, wiring, we've got a wire here wiring this first node up here, first node capacitor. So this is wired to this is wired to this, or which is this here, and then the resistor's wired to it. I sound like Columbo, don't I, doing that? So then we go through the 10k resistor, and that goes then onto the screens, and that wire comes to here. And then we've got a second node of the capacitor also going to there as well, because we need to smooth that node. And it goes on through this 10k resistor and feeds this capacitor here, and that's as far as we've got. And then we need to take a wire that will go down to the preamp section, the phase inverter and the 6SL7. So if we look at the 5Y3 schematic here, you can see that we're coming out the 5Y3 there. There's our capacitor, which is there. We're going through the 10k resistor, which is there. That goes to that second capacitor there as well, is wired on there, which is this one here, which we brought the wires around to there. That goes off to feed the screens here and here. We've only got one connected up at the minute. We've got a hole in the bottom of that pin to connect across to the second one. Note the 1k resistor there, 1k 3 watt screen resistor, because there's no screen resistors on a 5Y3, but we're going to put some on just to regulate the current on these tubes when this amp is cranked. So then there's the other 10k resistor coming from node 2 to create node 3, and that is that 10k resistor. That capacitor there is that one there, which is a 22. We've got 16 on here, but we've gone for 22. And now the other thing with this amp, because we've now got a really good transformer, we will have a lot more plate volts. And here we've got a 200 ohm resistor. Now that may not be enough now. We may need a bigger resistor. And if we look on here, this amp is cathode biased, and you can see this 5C3, you can see that we have a 250 ohm resistor there instead of a 200, and we've got a bypass cap. So that means that this will probably have to go, because I'm guessing that the voltages for this 5C3, this transformer, will be on a par. There's no voltages on the schematic. So where would we mount another capacitor? Well, me being of poor looks and menial talent has left an opportunity to mount the cathode resistor on here, on this section here. And what we would do is we would extend that ground if we need to, so we can use that pin, and that will give us some space to put a 5 watt resistor from here, which will be ground, and here, and then we'll connect on here, and that will go off to the cathode's pin 8. So that's how we're going to alleviate that, because I'm almost certain that's going to be gone. Well, the tubes will be over biased. I think they'll be about 14 watts. That's my guess, and that's too much. Although those RCA tubes, I think, are rated a little higher than, in fact, where's the receiving tube manual? Let's have a look in the book. So 6, because remember these are RCA. I could be wrong, but they're not just the normal run of the mill. The RCAs are very nice. 6v6. Maximum ratings. Well, according to this, let me just click that so we can get into operational focus. 14 watts. But we don't really want to be running those RCAs. Oh, sorry, we don't really want to be running those RCAs at 14 watts, do we? Because they are really nice tubes. They won't last as long. So the only modern tubes, 6v6 as I know of now, that still run at 14 watts are the 6v6S's that JJ do. The Russian 6v6s, they run at a dissipation of max of 12 watts. So that's where we are with all of this at the moment, and there's still quite a lot of work to do on this. And this is what happens, I'm afraid, with these amps. You know, someone bodges the wrong transformer on it, and then you've got other issues like, you know, trying to find the right capacitor to go on it, because if you remember, and if you've watched the other parts, you remember the capacitor that was on there. So you're then looking for a smaller bracket, smaller capacitor to go in there, and so on. Then you've got the tone control that's on the pot, which you don't want. So we put a switch in. We've got to change the power cord. Somebody botched the hole, if you remember. We've had to put this in because it's just a much better set out rather than what was in before, because it wasn't particularly secure. Then we had an HT fuse for more safety, and before we know where we are, we've completely rewired the power supply. Then the output transformer was no good, of course, so then we've had to put another output transformer on. So right up now, up to the plates and screens on this amp, so far it's been a complete rebuild. So it's took up quite a lot of time. Had it have had the right transformer on it and all the power supply had been in reasonable order, we'd have just put a switch on it, an HT fuse, coupler, the cap was already mounted, coupler, just a cap, and then this, and that's all we'd have needed. But I'm afraid now that's turned out to be a full rebuild, and that, as I say, this is what happens sometimes with these amps. So we're going to press on, but we're going to retire for lunch, and then we're going to come back after lunch, and we're going to press on, wire up the screens, and get the cable from here for the power supply. Then we can start looking at this section here, and then just going for the 5C3. I was going to power this up before I did the mods, but unfortunately wires are beginning to be disconnected more and more, and I think now I'm better off just blitzing the amp and getting it done. And then we'll have to power it up, look at the bias. I don't really want to bias those RCAs at 14 watts. I could do, but I don't really want to. Remember, we tested those, and they don't have a massive amount of life left in them. because those Sangamos have been leaking for a number of years probably, and they've sucked a bit of the life out of them. But they have got some life left in them, and we could do it preserving that. So maybe bias them round about 11 or 12. So he's going to have to go, I think. I'm not going to take him out yet, but I think he's got to go. He does look a bit precarious as well, doesn't he? That's the other thing with him. It's a rather strange looking setup. I mean, it is fairly secure, I suppose. Might have said that. Is it fairly secure? I've just undone that with my fingers. Yes, I think we'll remove that. I think we'll just, yes, that's got to go. That's shabby. We'll get rid of it. And we'll put a cathode resistor on here. It just makes sense. So what I'll do is when I've rebuilt the amp, I'll just jumper a cathode resistor in there. And then when we get the right one, we'll just solder it on there and do it right and get rid of that. Dear oh dear. Right, we're back outside again. We're also trying a new gimbal and some, obviously we're using the gimbal software. So this is a DJI Osmo Mobile 8P, and I'm going to be trying some handheld with this as well. So a much better gimbal, quite an expensive one as well. And I've had to switch the tracking off on it because Pink's looming around the amp, and it keeps, because she's moving, it keeps tracking her instead of filming the amplifier. So let's have a look what else we've done. And you can see I've removed some more wires on here, and it all starts out, well, I'll wire the filaments up to here, and then we've already got the filament wires, and then the more you start to look at them, and you just think, that looks naff. So they've come off, and you just know what it's going to be. I'm just going to end up taking all the wire off. And it's all this. You can see if I've got some pieces here, and you can see that they are just, well, that black one's all mouldy. That was off the cathodes. So I've wired up the plates, and I've had to join them here. Remember, we did a bit of a job on them just to get this amp running, but now I've done them properly. And I've decided to run the plate wires around here, all the way round to here. And obviously the obvious shorter route would be there, but you can see I've got the filament wires there, and I don't want those. I'm trying to keep AC and DC as much as I can apart. And then also it's coming round here and in all that maze, so I took all that maze off, and I thought, you know, I'm just going to run these, keep all the DC over here as much as I can. I mean, I've got a couple of wires. These wires are okay. I've got one wire running under these are DC, AC, sorry, but just trying to keep you know, everything separated as much as I can. Never easy on point to point stuff. So that's where we've got to at the moment. So now I'm going to wire the cathodes up, and we're going to wire the cathodes to here, and then we're going to put our cathode resistor between there and there, which will be ground. But we'll just put the wire on, and then we'll jumper the resistor in, because we're not sure what value we're going to want. So probably start with a 470 or something like that when we first power up, which will probably be too big, but we'll err on the cooler side. Well, you know, I'm trying to get it to look as tidy as I can, and it's not, point to point, it's not easy either. I am not, some people are masters at it. A lot of you guys in the States do a lot of it. It's not such a big thing over here, and I am not fantastic at it. I get by with it, but yes, main thing is to get it tidy, and above all get it safe and quiet. You know, we don't want it humming. So what I'm going to do with the filaments, I'm going to connect on here, and then, thank you Pink, yes, we're busy, go away. And then I'm going to put the filament wires over this way and keep them up in the air, again away from the grids, and the, you know, the signal path as much as possible. Where here you can see the filaments are all buried in there, and it's all mashed up, and you've got signal here, lay across filament wires, and we want to try and avoid as much of that as we can. Now hopefully this gimbal software will improve the lighting as well, because I was getting all sorts of problems with the lighting, but that to me looks much clearer and much more stable. So hopefully this should be a winner. And as you can see there, the boss is there. The question is she looking over the work and inspecting it, or is she pretending to, and she's just sat there waiting for more food? I'll leave you to make your own minds up on that one. Let me know in the comments. Now we've also got quite a good zoom on this as well, and if I zoom in there, you can see how clear is that. So that's a result. Right, I'm just trying this handheld now, this gimbal. So if we go in now, you can see I've removed all the wire. I just looked at that and thought, that's got to go. Gooden and Jeff will give me 30 lashes of the cane if I leave that wire in. I'm sure they will. So it's got to come out, so it's gone. Now this is the 6SL7 tube socket, and then this is the phase inverter here, but none of those values really, apart from the plate resistors, have got any relevance to that 5C3 schematic. And as most people who watch the channel regularly know, that I don't care for carbon comp resistors, so may take all of those out as well, because a lot of them are the wrong values for what we want. You can see I've wired the cathodes up there, and we've wired up to here. So I think what I'm going to do now, which is what most people do when they wire an amp up, generally start from the preamp, well I always have, and work my way to the power supply, where I've done this the other way. So I think now I've got to the tubes, I've got the screen resistors on there and all those pins wired up. I think I'm going to strip all of this off, wire up the filaments, and then I can wire around those, trying to keep all the signal wires away from them. Seems logical. Alright, so cleaned all that crap off there, and you can see now, just got to get the hoover in there. So all that's gone. Now the other thing we've got to do is we've got a ground point here, as you can see, and it's riveted, so we can't have that. So what we're going to do, I'm going to drill that rivet out, just move that out of the way, and then I'm going to clean all underneath it, shine all the metal up, and then we'll put a bolt through it, because if that relaxes, this amp will have all sorts of problems. Can't rivet grounds. Right, I've got the filaments wired up, and I've gone for going over the tubes, over the sockets, just to try and keep these elevated and keep them away from the signal path. Nobody likes doing filaments wires, surely, and yeah, they don't look the best, but we'll try it. If it's noisy, we'll have to change them, but I think that'll be okay. Now that another thing, if you're ever doing this, if you notice these two, the 6SL7 and 6, well, they're both 6SL7s or 6SN7, whichever. Pink's just bit me because she's not getting service. If you turn the sockets so you can keep the wire going on keep it on the outside of the sockets, if you mount that, that's the other way. You've got to go over the tube. See what's happened here, because they've mounted that, you've got to go over this first tube. So if that was turned round and mounted this side, then you wouldn't have to go over that tube, but unfortunately that one's been put in that way. There's more waffle. So that's that. Now if we look on here, we've got thank you, Pink. We've got 5 meg resistors here, and suddenly I thought, I don't have any 5 meg resistors. I've got some 2.2s, so I'm going to put these in series. These give me about 4.5. So that's about as close as we're going to get. They actually, well, they must be a bit over those, because they should be 4.4, shouldn't they? But they give me 4.5. So I'm going to use those. That's going to be near enough. I think though, the 75k, which you think, no, nobody's got that. I think I have got that. I think I've got some 75k resistors. I'm going to start wiring up this signal stuff, the inputs and things. But first, I've got the ground on this capacitor to come through, which we're going to put here, and then the live feed from here, which is going to go to these, and these are going to hold the plate resistors for each of these tubes. So that's where we're going to get the power. So I've left those in. This one's gone. I took it out. I started cleaning that to put it back in, and I thought, no, so I think we might do this kind of arrangement here, maybe, just to try and keep this point-to-point thing tidy. And for anybody who's thinking, why didn't you put a board in? Well, it's pretty obvious really where you're going to put it. You know, the sockets are mounted the way they are. Basically you've got 2, you've got that, the cap, and you've got nowhere to put a board. So, and you know, there was some real estate over here, but you're not going to mount the board in the power section, are you? So I'm afraid it is point to point, this one, all the way. Right, so we've made a bit of progress with some of these components. So you can see I've got the plate resistors. Now I didn't have 250k, but I had 240k. Who keeps 240k resistors? I do. So not too bad with those. It was either 220, 240 or 270, so gone with the 240s. So we've got those in. You can see here where we're feeding from here. We've only got 1 resistor fed from here, because we couldn't get round to reach to this one. But I've took this one from here, from this point here and up to there, and then obviously we've got the other 2. We've got the insulation, we don't need any on those, are too short. Same with that one. So those are all done now. Well, they're obviously not soldered at this end, but they're soldered at that end. You wonder why I left this on. That's for the cathodes, because the cathodes are joined together on the phase inverter. If we look there, oops, you can see the wind's blowing now. I'm afraid we're about ready for finishing. It's 7:20. So yeah, you can see the cathodes there joined, so that I've left that in. That was there from previous. So not found the 75k resistors yet. I think I've got a load of stuff in a box, and I think they're in there. Definitely, I found 750k, so I could be getting confused, but I think I might have some. If not, I suppose I'll have to go to 68 or something. But trying to get as close as I can with the components. Not easy though. So that's where we are. So we've had a day on it, and yeah, it's looking something like now, isn't it? But there's still a good way to go with it yet, but we'll press onwards tomorrow. Right, you can see I've fitted this in there, this tag strip, and we've cleaned him up with the wire brush in the drill. I've decided not to put master volume in this amp. It's going to be a bit of a pain. We need a double gang pot, and we're going to be struggling to fit it in really. The only place we can place that is between the phase inverter and the tubes, which is why the output tubes, which is why we need a double gang pot. But there's 2 things. One is major, actually, not major, but so I've decided to add a negative feedback switch to this amp, and the reason being is that if we look at the schematic, you can see that we've got 1 meg negative feedback. Now on a 5E3 there is no negative feedback, and obviously that amp is breaks up a lot quicker and is a bit more growly. Now although that is quite a high value, 1 meg, so what I'm going to do is add this switch. I've moved the inputs across now to the end, and I'm going to put that switch in there. We've just got to nibble the hole out, and the reason I've moved it across is because speaker sockets are here. It's quite easy to get that all rigged up from there. Now here comes the second thing. So this is a major Planck moment, and it has scored 99.5 on the Planckometer. Now I've tried everything to keep the filaments away from the signal path. We've raised these, we've pushed this under here, we've brought all the DC round here going in, we've done what we've done, but I've forgotten something. Has anyone guessed what it is? It's the pilot light. Now the pilot light is on the front here, which is one of the reasons why I forgot it, because it's not in here, and just never thought about it. So people thinking, well, there's no big deal, is it? You can just wire that back up, 2 wires, connect it to the tube sockets, and that's you'd be correct in thinking that. But the problem is, if we look here, there's the, oops, sorry, not looking down the camera properly. There's the pilot light there, and so the wires have either got to go down this hole or this hole. So let's have a look at that. So if it goes, now moving that across there has made things better. So if I bring it through here, what I'm trying to do is keep it away from the signal path. If it comes through anywhere here, we're gonna you know, end up with it in this signal path. Might be able to bring it through there and connect straight on, and then we've got this, we'll be going, we'll have to put that there. So we could bring those wires from that pilot light through here, but we need to connect it to this tube if we do, and not this one, because we don't want to be coming anywhere near these tubes. I mean, I suppose we could, no, we're probably better off trying to connect it to the, I've already got 2 wires on there. Just gets a bit much on the 2 pins where I've only got 1 on here. So that's a bit of a Planck moment there. Just completely forgot about that, out of sight, out of mind. We've not really even looked on this side panel. We've not really had a reason to as yet. We've not started to wire things up. It was only when I actually started looking at the tone control, and then I suddenly looked and thought, oh dear, you Planck. So anyway, we'll deal with that later. So we've got this tag strip in here, and one of the reasons we've got this is obviously to connect some of the components. Now some of the components will go straight to the pins on the tube sockets, so such as this point 1 here will come straight off the jack socket, connect to the grid. But then you've got these here, well, that can connect to the pin. We've only got and obviously that one can connect to the pin on that side. They could just connect to ground. But here we've got 75k from the pot, from the socket, sorry, we've got 75k from the socket, and then we've got the 0.1. So we need a connection point for there, and which is why we've got this. And we'll find as we're going through this, we're going to need more connection points for various parts. So for instance, these here, these will need, because you can't just keep tacking resistors together and leaving them floating. You've got to have a solid point of connection. So that's why we've got that in there, and hopefully that should be enough. We shouldn't need any more. Not that if we do, I don't know where I'm going to put it. we need to keep all of this signal wiring over here now. And this is one of the problems when you're doing these type of amps. You're kind of doing this on the fly. You start out thinking, well, I'll just do the power supply and then we'll just convert a few bits, but then you realise as you're going through it, you know, that's not going to work. So we stripped all that out to do that, and then suddenly we need a tag strip here to build all this neatly, and so it keep adding things. And yeah, fun and games, but we are getting there with it. And remember, I'm a repair guy, not an amp builder. I have built amps, but somebody who builds amps every day and just focuses on building amps, he's always going to be well in front of me doing this, especially in time. You know, they'll do it in half the time. I don't do this every day. I repair things. I don't build things as a rule. And this started out as a bit of a repair and modification, but it's turned into a full rebuild. Right, so we've wired up this first 6SL7 for the channels, and I had a bit of trouble getting these in because of the size of them, and really any decent 0.1s are going to be a bit of a nightmare. Just where these sockets have been mounted, with the socket and the jack and the tube socket being there, there's just not enough space, but we've managed it. It looks a bit untidy, but we've managed it. So we've got those in, and then we've got the 47s going to the pots. One of the pots was damaged, so that's had to be replaced. So we've got a new pot in there. Right, let's just have a look at what we've actually done then. So if we look at this, you can see we've got the 75k here coming from the socket to the 0.1 and then into the grid. So if we look, there's our 75k, there's that fastened onto the tag strip here, so that goes across, because these, obviously you can see how these work. So we're wired on this side 0.1, and that goes to the grid of the tube. Now those resistors, this one and this one here, these resistors, now I found those are 4.7 meg, but they're a little bit over. So one of them is about 4.9, I think one's 4.85, something like that. So they were just in a box when I was looking for the 75k. Found those as well, didn't know I had those. So we've got that wired. So if we just have a look again, you can see the cathode is joined together. Both cathodes on each triode are joined together, and then they go to ground. The two 5 megs go to ground, and if we look here, this is going to be our ground lug. The cathodes are joined here with this wire 3 and 6, and joined here, and you can see that coming in there, and then that will go to ground. The other end of the 4.7s are going to the grid pins on each grid, because if we look here and here is all the same. You see how that works. So I'm not explaining this very well. So the other input is here, and that's just a 0.1 coming from the socket to the jack socket straight in to the grid. There's the 0.1 on that one coming straight from the jack socket into the grid. So that's the difference between those inputs. One has the 75k resistor before the 0.1, and the other one just is 0.1 straight into the grid. So that's that tube. Coming out of the plate of that tube, we've got both plates there. One is going through here to the wiper of the pot, and we've joined that little bit of screen cable there, and that joins onto here, and then we've come across with the 0.047 into the wiper of the pot, because that wasn't long enough. This one on the other channel comes from the other plate, and that goes to the wiper of this pot here. And if we look on the schematic, you can see that We're coming out of the plate through the .047, although it's 0.5 on here, and then into here, and the other one is coming into there. Now this is the tone pot, and that's the next thing we're going to be looking at, and then we've just got the phase inverter to wire up. So it's a bit tricky getting those in there because they're a bit large, and obviously I've got other capacitors, some radial ones and stuff, but I wanted to use this as a vintage amp, so I just wanted to use these mustard caps. So I've squeezed them in. As I say, it doesn't look, but point to point never looks that tidy anyway, but we've squeezed them in. We've got the insulation on them, and yeah, they will suffice. I've wired one side of this switch. This is going to be the negative feedback switch. I've wired one side of that to the speaker socket, and we've got the other side which will be going into the phase inverter with a 1 meg resistor. Well, it actually goes to the grid of the 6V6, and the other side comes down here, and then that all goes into the phase inverter, so it's all part of that circuit. Something like that. It's getting late in the day. Right, we've finally got it all wired up, and we're going to run it up now, and then I'll go through the rest of the wiring the circuit when we've finally got it up and running. I've got 430 ohms cathode resistor jumpered in, which is actually 424 ohms. So that's what we've got in at the minute. And then I'm using this analog meter for a change to monitor the cathode voltage, so we can keep an eye on the current. Now I haven't got those RCAs in. I've got just a set of test tubes in there. I'm not putting those in yet. I've got a meter upstairs on the shelf. If you've been seeing me do this before, usual deal, monitoring the HT voltage. We're going to kick off, and as you know, whenever I've done something as large as this, it seldom works first time. There's usually some mistake that I've made. They're never serious mistakes, they're usually signal path mistakes, as most of the ones that I make. But yeah, let's see if I can get through this one without making any. So we're going to start with a 40-watt bulb. Oh, I've just realised I need to put an HT fuse in. Just hang fire. I've got some fuses in there, and I've changed the power fuse as well, because of course this amp was 110 volts before. We changed the transformer, so there was a 3 amp fuse in it. I've changed that to 1.5. Right, let's go. Put the bulb in. Nothing, and that'll be because I haven't plugged it in, which is another one of my usual tricks. So we'll plug in and off we go. Now I've got a solid state rectifier in as well, because it just makes it easier to well, we're up and running already. Blimey, on a 40-watt bulb. That came up like one. Right, so now we've got signal. I've got a slight problem here. That channel is okay. Just turn the signal generator off because it's just annoying. So I'm missing a ground somewhere there, but nothing major. Tone control appears to work. We've got a microphonic tube as well. So we go across, you can see we've got 230 volts, 31 volts on the plates, sorry, on the HT. That's not plate volts, that's HT volts. We've got 140 volts going in it, and we're drawing 100 milliamps, which is not a lot. So we've got 12.7 going on there across the cathode resistor. Divide by 2. It's only got 14 milliamps on each tube, but then we're only on a 40 watt bulb. We'll go up to a 100 watt bulb, I think. Oh yes, we really have got a microphonic tube. Oh dear. Yes, that's the 6SL7 on the phase inverter, I think. Let's just try it. Is it? Probably both are. But we'll worry about that later. Now we've got 20.6 going across that cathode resistor. So now we're drawing 24 milliamps. We've got 204 volts going into it. Remember, when we come off the solid state rectifier onto the 5Y3, we won't have as much voltage. Right, we'll shut down, and what we'll do is we'll put the RCA tubes in now. Right, we've got the tubes in, the RCA tubes, so, and you can see those tubes aren't drawing as much current. Let's see. Oh sorry, I've got the current limiter on. They're just while I fired up. Right, let's see what they're drawing. We'll just give them a minute or two to swage. So let's see what these tubes are drawing. So we've got, we'll call that 20.5, divide by 424, divide that by 2. They're drawing 24 milliamps. So let's do a plate to cathode on those and see where they are. So here, this plate here, they're giving me 364.5. Now, I've not taken away 5% for the screens yet. So they're only doing 8.8. So now we need a smaller resistor, don't we? Cathode resistor. And if you jumpering in cathode resistors, make sure you unplug before you change the resistor, because if you get between that cathode resistor and ground, you'll have a new hairstyle. Unless of course you've got no hair like me, but it won't be pleasant. And what I mean is, by jumpering resistors in, we're doing this, and it's dangerous. If you're doing it while it's plugged in, don't do it. It is dangerous, because this cable here is the cathode cable. So if you're touching that and you touch the chassis, or you touch the other lead which is wired to the chassis, it won't be pleasant. So don't take risks. It's easy just to unplug it. Tip for the day. And if you do want a new hairstyle, go to the hairdressers. second tip for the day. Right, so we're on the 390. Sorry, the 300. Got 390 on the brain. That's 300 ohms. So let's see what that's giving us. Rough window. 17.5 divide by, we didn't measure it, but we'll do 300. Didn't measure it full. Divide by 2. That's 29.1 milliamps a tube. Let's go plate to cathode. So cathode is there, plate is there. 356. That's bumped them up to 10.3. Right, so I've put a 220 ohm resistor in and I've got them down to 11.76 with 241 volts on the wall. So I think 240, I've got some 240 ohm resistors somewhere. I think that will do it. But yes, so that's pretty much the bias sorted now. That sounds quite nice, and that's on a rubbishy speaker. Let's flick the negative feedback out. Actually, that. And that resistor's so big on that negative feedback, we could do a reducing that. My, that sounds excellent. Now you may, if you're looking in there and you've been legging at some of the components, you may notice, such as here, we've got two resistors. I'm just going to unplug two resistors in parallel. And that is, if we look on here, just remove those now. That, if we look, is this resistor here, 25k. Now obviously we've got no 25k resistors, so it's either going to be 27 or 22, but I had a couple of 51s, so I paralleled them and I got that to be 25.5. and as I've said, you know, I've tried to get this to the spec of the schematic as much as I can, and that's normally when I'm doing these amps, they tend to deviate off slightly. So, but we've tried to keep this as close to the spec as we can, because we said we'd build a 5C3, so that's what we've built. So really, if you know, we've dropped off an input, but that really doesn't matter. We've got 4.7 meg here instead of 5. We've got the obviously these are 0.047 because you can't get 0.5s anymore. Well, I don't know, I've not seen any. We've got 1 meg resist pot, so we've got that as normal. 2500 for the cathode resistor on the 6 6SL7. I know it says SC on here, but we've got 6SLs in here. They're the same amplification factor, so they're just, the only difference is the cathodes aren't joined internally, but they're the outer tubes that came with the amp, so that's not really much of a change either, to be fair. And so where's that cathode resistor? It's here, and again you can see that I've got two resistors in parallel there, 2500, and they are, one is a 5.6k and one is a 4.7k, and that gave me 2.55, 2.59, 2.56. There we go. So yeah, I put a 5.6 in and a 4.7, and that got me the 2.5 that we needed for that. So I have tried to get the exact spec, or as close as I can, with these resistors. We've got 240 ohm plate resistors instead of 250. Sorry, 240k instead of 250k. Because the things that's been added are the screen resistors at 1k at 3 watts and 1.5k grid stoppers there on the output tubes. So they're, you know, they're different, but we've got the same drop in resistors on there. Yeah, 32 on there. Well, we got 16 on here, but we're not going to, seriously, we're not going to put that lower capacitance in. That really wouldn't be a good idea. You would end up with, you know, background noise. You'd have that 50 hertz hum. 22 instead of 16 on there. So obviously it's now got an HT fuse it didn't have before, and the 5C3 doesn't have one. When we've got this switch in for to switch the negative feedback in and out, so we can just get that added feature of the 5E3 with no negative feedback. Some of the components we've got exactly like the 75k. We got that spot on. We've got that. So yeah, as I say, I've tried to keep this at spec. So do I change the negative feedback or not? I think if we lowered that resistor, we'd get a more, you know, a more cleaner tone. But let's get it running right first, and we can worry about that later, can't we? Right, let's get this cathode resistor soldered in. I've got that cathode resistor in and bypass cap there, you can see, and I've got the bypass cap away from the resistor, so don't want to get any heat around it. The other thing we have to do is put that pilot light on. Now I haven't done that yet, and I'm going to leave it till I get this amp right, and then I'm going to add it and see if it causes any problems. It shouldn't do, but now I've got the bypass cap on. Oh yes, we've got a lovely fat tone now. That's most delightful. Wow, that sounds great, and it's only through this crappy speaker. Wow, that sounds awesome. Right, lesson learned. Never leave the last original component in the amp. The only original component that was left in this amp is this, apart from the fuse holder, sorry. So 2 original components. This is faulty, and I thought there was something odd with it because it wouldn't turn completely down. I could still hear the guitar when it was on the stop, grounded out. So this is now one of the channels turned up flat out. and this is the other. And that's all there is. So it's as quiet as a mouse. It's also incredibly loud. That power transformer from modulus amplification packs some serious plate voltage. It's an excellent transformer, really is bang on. This amp is superb and it sounds awesome even on a crap speaker. So what I'm going to do is I'm going to wire, now I know this amp's really quiet and I've got it how I want it, I'm going to wire up that pilot light, and if it doesn't affect, you know, if it's still quiet when I've wired it up, we're going to bring it in here. If you can see, I'm just going to, just don't like touchy chassis when they're live, when I'm looking through the camera at the same time. So we've got a grommet there, we're going to bring it through there and we're going to connect it onto this one here, which has just got the, obviously this is the end of the parallel chain, so there's only one wire on each tube socket there. So we're going to pop it on there, and then I'm going to test this amp again, and if it's still as quiet as it is, then we're fine. If it makes the amp a bit noisy, you see the problem with the pilot light is it should be down this end of the amp. It shouldn't be up where the preamp is there. We really don't want a pilot light there. I'll just unplug this. And this, because this is such a strange design of amp, really. It really is. Oh, and I've sorted out the, I've swapped the microphonic Russian 6SL7, and I found a very nice Joint Army Navy one. And I've put that in it, and that's sorted that problem out as well. So it's getting a bit messy on here. We've got bits and bobs, so that sorted that out. We've 500 picofarad should have been on the tone control, and 5 nanofarad. I used to have some Lemco 5 nanofarad caps, but they got used. So I've got a mustard cap 4.7 I found on there. There's no DC to block on it or anything, so there's no voltage, it's just signal. And I've got a 560 on here, and I've got a mica on there. Now I had got some 470 picofarad, but they were ceramic caps, and as you know, I've stopped, if you watch the channel regular, I've stopped putting ceramic caps in tone stacks. I don't like them, they just seem harsh. And I'm not massive on capacitors, you know, but there is a noticeable difference when you put them in. And I think it was that Marshall 75 that we did, where we put one in the tone stack, and it just didn't, when we turned all the treble out, it just didn't work properly. And it was harsh with it in, but when we put the mica in, it just smoothed it out lovely, and it just worked a treat. So since then I've been trying to use the mica. So obviously didn't have a 500 pico, so we've got 560 in there. It's a little bit over, but not much. So as I say, I've tried to keep this amp as close as I can to its original spec. Here's the pilot light. So we certainly don't want to be coming down here where these wires are. And these are going through that brass grommet there that we've got. Another brass grommet there. But we've got this hole over here. Now, again, it's going to be passing the preamp tube, which is the phase inverter. So it's going to be, you know, this is what we've got to watch. Keeping that away from that tube. But we're going to have to try it and see. Now, the only other thing with this amp is the negative feedback, which I actually questioned on this amp. Now, the negative feedback switch doesn't seem to make a whole lot of difference. And that's probably because that negative feedback resistor, which if we look on here, is 1 meg, which is here. It's quite a high value, really. But again, I've tried to keep this amp to its original specs because, you know, in the past we've built amps and, oh, let's build so and so, and then you know, we've changed half the components in it. I've tried to keep this as close to the original. It's a 5C3. So my question to any, you know, all the techs that are watching and people who are good at this, and some of you are a lot better at it than I am. Remember, I always class myself as a guitarist and a competent tech. I'm not a master of this, and, you know, I'm not a master amp builder either. But for all you out there, would you lower this 1 meg resistor on the negative feedback, or would you leave it as it is? The switch, as I say, I put the switch on because the 5E3 doesn't have any negative feedback, so I just thought I can add that as a feature. You know, I've not really modded the amp circuit, have I, by doing that? I've merely just switching a bit of the circuit out and switching it back in. But would you lower this to get a better effect on this switch? Let me know in the comments. And remember, you know, this channel, it is a community channel. It's not like other channels. You know, when I do stuff on here, you know, I put everything out into the you know, into the subscribers and the people that are watching, for them to, you know, add their opinions to it, because it's, you know, it's a community, this channel is, so it's a knowledge base for everyone. So anyway, I've waffled enough there. So I think what we're going to do now, in fact, I think what I'll do is, I think we're going to demo this amp now. So I'm going to wire that pilot light up after the demo. I'm going to get the video out. If I wire the pilot light up and it works fine and there's no problems, then take it as there's no problems. If there is a problem, when I, you know, it's affected because it's the wires are running close to that tube or something, I'll then what I'll do is I'll do a follow video of that. Now, I could bring the wires out, try and bring them down this edge, but and then drop that in there. We have got the cover to go on. Just trying to keep it away from that tube. Let's have a look what else we could do. Don't want it coming in there. Yes. So we've just got to hope that that doesn't, and there's nothing we can do, it's just the design of the chassis. The only other thing we could do is move it down to here and put it on the side somewhere, or, you know, we can't put it over here because we've got no real estate left, but we have got room to pop it on there, or we could even pop it somewhere just in the, you know, here. It wouldn't be too bad. So we'll try it anyway. Enough waffling, we'll try it, but we'll demo this now. We'll get it on the 4x12, because it's got to go on the 4x12, and we'll give it a demo. Right, we're ready to give this a demo, and you've not seen this before, have you? I don't get this out very often. This is a Gibson Explorer Studio, made I think in 2004. It's as light as a feather. It's made of basswood, like the Ibanez guitars. It's got Seymour Duncan mini humbuckers in it. Probably owned it about 10 years now, I think. About 10 years ago since I bought it. In fact, it might be even be a little before that, but around 10 years anyway. But yes, it doesn't come out often, but it's come out today. So let's have a listen to this amp and start waffling. So. That sounds most tasty. so on and so on. Let's try the other channel. So this tone control is quite interesting as well. You can see I've got this on about number 6. So obviously we take it all out. It really does stifle off the volume. And I mean, it's wired as it is on the schematic, so, and it's the same value pot and everything, so we don't know. And when you start to turn it up, it really boosts the volume of the amp. So I'm not sure what's happening with that, but that's how it's wired on the schematic, so I don't know. Maybe that's how it was, I don't know. It's interesting. Yeah, really strange. She starts acting like almost like a volume boost. It's just that's how it, as I say, it's wired how it is on the schematic, so I'm not sure about that, but you can always use the tone control on the guitar, can't you? It's a strange thing that. Let me know in the comments if you've, because I've saying never used this circuit before. It's it's a new one to me. Now I've got the hot plate here because this thing is so loud. Oh, look at that. And I'm going to just knock it down. -8 dBs. That needs a bit of gumption. Little bit of blocking distortion, isn't there? And again, when we looked on the schematic, if you notice, there's no grid stoppers, there's no mixer resistors between the channels either. This is a very early design. You know, normally you'd see a couple of 270Ks there, and again that that would stop some of the blocking distortion. There's not a lot there, but there is some. Tight sound though, very tight. Yeah, the tone control's not fantastic on it, but as I say, I presume you know it's an old circuit design. That's why it just kept getting modified till it got up to the 5E3, I guess. Let me know in the comments. Right, that's with the negative feedback switch on. Let's switch it out. Well, that does work now. Or does it? Not sure. Yeah, it just tightens it up a bit. So that's off now, no negative feedback. Oh, didn't get that, did I? That's what happens when you get rusty. Yes, that's let's try the other channel then. The other channel. That channel is the one with the 75k grid stopper, hence it's not as bright. Remember the other channels, just if you remember, is just the 0.1 from the socket going straight into the grid of that triode stage. Transformers lukewarm, and that's been on a while. Quality. Yeah, that's nice. Let's go on to the neck pickup then. practice more. Very rusty. Now I did put a coil tap on this neck pickup, which is on, so if I knock that off, of a lazy palm with being rusty. Don't quite moot all the strings out. So there we go, that's very tasty. That just sounds absolutely awesome. Tone control's a bit odd, but as I say, it's wired to the schematic. It is a little bit odd. I don't so much the actual tone circuit is not particularly odd. I think it's just the way it's wired in there between the two channels. But don't know. Maybe I should have put a 470 on there instead of a 560. Let me know in the comments. But yeah, let me, if you've used a 5C3 before, let me know. Is some of these characteristics, are they normal? Don't know. But by gum, that does sound good. Really great. Yeah, transformer's lukewarm, and we've had that flat out, really, proper beating it. So yeah. So that'll do it for this one. So I'm going to get that pilot light wired up. Just make sure that's not making any noise, causing us any noise issues. It's in an odd place, isn't it? But yeah, that's flat out. And there's probably a tiny little bit of 50 hertz hum, but then we've only got 32 microfarad of capacitors. We'd have preferred 50 on this amp, but we've got the 5-wire 3. But anyway, that'll do it for this one. So thanks for watching, and you all take care, and I'll see you all in the next video with the yellow guitar. Bye bye for now.